Welcome to my fourth, and for you guys, probably the most interesting of the student videos in terms of topics. A great topic. These students have chosen to talk to you about imaginary numbers and where they come from. Not necessarily how they're applied, but it's a great little intro, and there's a question at the end for you. So they've done everything I asked of them, and I hope you haven't got sensitive ears.
You probably become accustomed to the idea that a square number is always positive or zero. For example, 2 squared equals 4, and minus 5 squared is 25. As a negative number multiplied by another negative number equals a positive number. But imagine there's a number that multiplied by itself equals minus 1. Let's call that number I for imaginary. Therefore, if I squared equals minus 1, I equals the square root of minus 1. This might take you a little while to get your head around, because it kind of goes against everything you've been taught, but once you get comfortable with it, it's really useful, as it means you can solve anything requiring the square root of a negative number, so all quadratics are solvable.
Therefore, whereas in your core units, if you got something like x squared equals minus 1, you'd have to put no real solutions. Now you can write x equals I. Following on from this, the square root of minus 4 is 2i. As by treating the root of minus 4 as a surd, you can separate it out to the root of 4 multiplied by the root of minus 1. As the root of 4 is 2, and the root of minus 1 is I, the root of minus 4 is 2i. You can probably see from this that the root of 9 is going to be 3i, and so on.
Let's look at an example. Using factor theorem, we find that by substituting 3 into the equation, the function equals 0, as 2 lots of 3 cubed minus 8 lots of 3 squared plus 7 lots of 3 minus 3 is 0. So, knowing that x minus 3 is a factor, we can use algebraic long division to try and find the other factors. So, dividing 2x cubed minus 8x squared plus 7x minus 3 by x minus 3 gives 2x squared minus 2x plus 1. Now we can attempt to find the other values of x using completing the square.
So like we did before, we're going to treat the root of minus a quarter as a surd and separate it out into root a quarter times root minus 1. The square root of a quarter is a half, and the square root of minus 1 is I. So the square root of minus a quarter is a half.
Now for a challenge. This should be fairly simple if you followed everything so far, but there's a little twist that might trip you up. The quadratic I'd like you to solve is x squared plus 2x plus 6. Good luck. And I'm going to leave you with a joke. What did the root of 4 say to the root of minus 1? Get real.